Time start now. I can.
Samuel, you didn't snap your note again.
Hello, ma.
You didn't snap your notes.
Sorry, I wanted to write that thing
And I
that Wilson
start with
said he was going to
you record your
give.
screen. I've made you host. Then you
All
make,
right.
make this guy host once you have done. Elvis. So Elvis can take control.
Sorry,
Okay,
I
guys,
beg. Okay.
can you hear me?
We can,
Yes,
Yeah, can
we
you
can
hear
hear
me?
Okay.
yes.
How far, guys? You guys will record this class too, Abby. Hmm?
Yes, yes, you are recording it, bro.
Okay. Welcome to the second tutorial. Today we are going to be talking about the Denavit-Hartenberg convention, aka DH matrix. Okay, we all know that this is a better way to get our coordinates. What do I mean? I mean that instead of doing the rotation matrix, the homogeneous um, the homogeneous transform matrix, instead of getting our displacement vectors, all those things we can do together in just one convention, which is called the Denavit-Hartenberg DH. So today we are going to be learning the DH matrix. There are some things we need to know. The DH matrix is okay. Let me just say the similarity between the differences between the direct method and DH matrix. By direct method, I mean the normal finding the rotation, finding the displacements, and so on like that. That one is very flexible in rules. It's flexible in rules in the sense that you get what you want sharp sharp, but it's bulky in computation. Now imagine, remember the first class, now we have to start calculating R01, R12, R2, all those things. So it's very, very bulky. Yeah, what's that? Okay, let me just continue. Then in DH matrix, the DH matrix is complex in rules actually, because it's either you know it or you don't know it. But when you want to get your computation, it's very, very easy. From the matrix, you can get your R, you can get your H, just plain and simple. So today we are going to be doing DH matrix, and Mr. Raji made it clear that the standard DH, that's the one that Sponge textbook uses, but J. Craig uses the modified version. Either ways, I don't even know which one I'm doing, whether it's the standard DH or the modified one. But I'm working with that tutorial link, the playlist that was sent to the group chat on YouTube. That's Angela Sodman. That's the one I'll be using. Okay, so we need to consider the two parameters. There are two major parameters. Okay, two classification of parameters in DH matrix. The first one is the rotation parameters. Rotation parameters. And under the rotation parameters, you have theta and you have your alpha. Now, what does theta mean? Theta is the joint angle. So the angle of rotation, that's what theta is. Then you have your alpha. Alpha is your link twist. We'll be seeing the difference between alpha and theta when we start. Then also we have the displacement parameters. These two are the rotation
What you
parameters.
said theta is what?
What do you say?
You said theta is what?
I said theta is the joint angle, while the alpha is the link twist. Okay. Then we have our displacement parameters. The displacement parameters is D and A. Sorry, some textbook use, instead of A, they use R. I think I should just stick with R in this case. D and R. All right. Okay, so D here is our, people call it displacement vector because from the normal direct method we use, we know that D is our displacement vector, and it's the same thing we're still going to be doing here too. But our R is our link length. Link length is our R, so it doesn't have to be a displacement vector. So we'll also see the difference between these two. All right. So this is a, I think this is a rotation. This is a articulate manipulator. It is not complete in the sense that it's supposed to be R, then the end effector. So we are going to be calculating the DH parameters from here down to here to the base frame. So let's start. Any question before I proceed? Anybody, any question? If you don't understand it, it's better I should explain what D and H now, because by the time we start, it will look very, very confusing. If you don't understand what D is or what H is, or what R is. Anybody, any question?
What of theta and alpha? What do they represent again? Theta and alpha. Come again with that.
Theta represents the joint angle. Alpha represents the link twist.
Okay.
They are both rotation parameters. That is parameters that tells you that a frame has been rotated. That's just what it is. Why the other one, D and R, they are just displacement parameters, distance between a particular place and another place, maybe in the X or the Y axis. We are going to get to that. Are we good to go now?
Yeah. I'll continue.
Okay. So the first thing we need to know is that first we are going to draw our table. Any table we are doing for DH in parameter, it always has to be 4 columns because of the parameters, the theta, the alpha, the R and D. It always has to be 4 columns. So the number of rows is not determined by our number of frame. So let's start with 4 columns. 1, 2, 3, 3, and 4. Right? So here is going to be our theta. Here is going to be our alpha. Here is going to be our R. And here is going to be our D. Right? So let's just...
Wait, Samuel, sorry. You said the number of rows is determined by what?
Number of columns is only 4. The number of rows, I'm getting to that, is determined by the number of frames we have. Now, yeah, this is frame 0, right? Shebi? This is frame 1. And this is frame 2. So the number of rows we have will always be a frame lesser than. So now we have 3 frames. That's counting from 0, 1, 2. But in actual sense, we are going to have just 2. We are going to have just 2 rows, which is going to be 1 and 2. Because look at it, the frame rotation between 0, 1, it will be written in 1, and the rotation between 1, 2, it will be written in 2. The DH of 0, 1 will be written in 1, and the DH of 1 and 2 will be written in 2. Is that okay? Do you get that?
Please come again, bro. Please, just.
Okay. I said the DH parameters. There are DH parameters, the rotation parameters and the displacement parameters. Rotation parameters, that's theta and alpha, which is the joint angle and the link twist. Then we have the R and D. D being the, some call it joint offset, or me I call it displacement vector. It's the same thing, but R is your link length. These are displacement parameters. These are rotation parameters. So we are always going to have 4 columns. But the number of rows will be determined by the number of frames we have in our manipulator. Now we have frame 0, which is the base frame. We have frame 1 and we have frame 2. So the number of rows will actually be 1, 2, 3, but we're just going to use 2 because from here to here is 1, from here to here is 2. You get?
Samuel, from where to where is 1 and from where to where is 2? Please, I didn't see that.
Look at it this way. Look at it this way. You know, normally when we are doing rotation, we do R0, 1. Shebi, that is the rotation matrix from here to here. Okay, let's say we want to calculate rotation matrix for this one. There are only 2 possible rotation matrices we can calculate. That's R01 and R12. Even if there are 3 frames. I think what's just confusing people is because frame always start from 0. Okay, let's put it this way. The last number of frames, number of row you're going to get. Since we're always starting with 0, and at the end of the day, we'll count 0 as 1, 1 as 2, 2 as 3, and we'll still minus 1. Let's just say the ending of the number of the frame number for the end effector will be your number of rows. Is that okay? See, let's put it this way. It's like if we have A, B, and C. I mean, I was calculating year to year and year to year. Actually, we have 3 points, but we are calculating what? Like just 2 stuffs in between them. Just like the shortest distance between 2 points is a line, you get. But they're actually 2 points. But that's no way. I'm not interested in the points. We're interested in what is joining them. So here too, there are 3 frames, but we're interested in what is joining this frame to this frame, which will be taken as 1, and what is joining this frame to this frame, will be taken as 2. Understood?
Yes, sir. Yes, sir.
All right. So let's proceed. Okay. So there are many definitions. I cannot start saying everything. They'll start telling you that the direction of the joint axis is taking about z n-1. This one n-. I think it will be too stressful to cram all those things. So I'll just be explaining it and you get it instead of cramming those definitions. Those definitions will not actually do any good. You get what I'm saying? So let me just be explaining how it's gotten, then you just be following up. That's the best thing. Because if you say you want to start explaining the definitions, you will just get the whole thing confused. Like the definition of theta, the definition of Kini, they'll tell you about this axis, next one about that axis. Just listen and you are going to get it. So let's start. I'm coming, please. Okay, let me check for this. Okay, the first one now, we're about to get theta. So we are looking at the relationship between 0 and 1. Like, who can tell me what connects this 0 and 1 together? Anybody?
That's a word.
Okay.
No, can you make
I don't understand. Okay. The theta is defined as the rotation between these two. So what's the rotation of this frame to this frame around Z? That's what theta is. Guys, do you understand what I just said? The rotation of this frame and this frame around Z, the former Z, that's what theta is. So you can tell me what is the rotation between frame 0 and frame 1 around Z? I need response now. I want to be sure you guys are following.
I don't understand this question.
You don't? Yeah?
I don't understand the question.
Theta, the first one, the first parameter, theta, is the rotation of this frame to this frame around Z. How will you rotate this frame to this frame around this axis, this Z1 here, this Z0? So how do you rotate this around sorry, I'm just saying around. How do you rotate this to get this around Z?
I think 90 degrees. 90 degrees anti-clockwise. That is opposite 90. Am I correct?
No.
You rotate about X.
Is it wait? what axis exactly are we rotating? Because if it's Z1 to Z0.
The Z0 axis. Forget about the similarities. If okay, let me put it this way. I know that Y1 and Z0 and Z1 they are not aligning, but that's not the problem. The X1 and X0 they are aligning. Okay, that's all right. But how do you rotate this around this? You know, X1 and X0 are already aligning, so we don't need to these frames they're already correct already. Do you get what I'm saying?
Yeah. Continue.
This frame and this frame, they are not exactly the same thing. X0 and X1 are in the same direction. All right. But what are we going to rotate? It's just very simple. It's theta1. If you are going to rotate it, we don't know the value of theta1. It was not given. So it's just going to be theta1. Assuming we are rotating to the exact base frame now. Let's say we want everything to match exactly. That is X1 should match X1, Y1 should match Y1, and what's the name? Okay, let's say X now. Let's say we are rotating about X. This one. We want to, these two now, they are the same thing. Let's say we want to rotate about this. This would have been 90, so that Y0 can come to Y1 and this Z0 can face here. But we are not rotating about X. The value of theta is the rotation of frame 0 to frame 1 about Z0 axis, irrespective of how they look. So whether they look similar or they don't look similar, what's the rotation about Z axis? And that's theta1. Do we get that?
Yeah.
Please, who doesn't understand what I just said?
Can you come again with that, please?
I'm sorry.
Samuel, please explain again, I beg, please.
Sorry, we're slowing you down, but I don't understand.
Okay.
Explain better, please. Thank you.
Can you, Samuel, can you clear the board and make a fresh drawing? Maybe you can understand better.
Fresh drawing.
If you don't mind.
That would take time. Like I should clear all this X, Y.
Because it's kind of confusing or something.
If I do this now, I have to start labeling
I'm sorry
everything. It's going to take enough time. That's why I don't want to do that. I have to start labeling. The
Okay, you can just explain. Don't worry.
See. Just from this place. What we need to do is that, see, frame 0 and frame 1. Before what we are doing is that we have to rotate it so they look exactly the same. Now, we have to rotate it so they look exactly. I think the reason why you don't understand what we are doing is that because you didn't attend the first class. We explained rotation matrix, homogeneous matrix, and all those things. This one now, X1 and X0, they are in the same. X0 and X1, they are in the same axis. We are good to go. But that's not the problem. It's not even making sure that both of them are aligned like perfect. That will be rotating about X0. But the definition of theta. The definition of theta is what are we going to rotate about Z, not X. So leave X for now. Forget that the two frames are not the same. How are we going to rotate Z? Z can only rotate around theta1. It's very simple, plain and simple. Forget whether the frame is going to be look the same or not. What is the frame? Let's put it this way. What is the angle that frame 1 can rotate with frame 0 can rotate with frame 1 around Z0? That's if you check your book where you say you see I'm trying to look for that definition. It says Zn minus 1. What is just telling you that rotate the first frame and the second frame along the axis of Z of the first frame. Do you still understand? I'm speaking jargons.
We understand.
Sorry, I don't understand.
Yeah, I continue. You see, when we are learning this, you will read the first this thing again, the first meeting.
I think that's why I made mistakes. No. Why I made mistakes is that I should have just let you people.
Just one more time, please. One more time.
I should have let you people cram the definitions of this thing, even if you will not need it. Like just cram what theta is, the rotation of this to this around this axis. What alpha is the rotation of this to this around x1 axis. You should have just crammed that definition. It would have been easier for me. I think that's why I made a mistake. What I'm just saying right now is that how are we going to rotate frame 0 and frame 1 along Z not axis? How are we going to rotate frame 0 and frame 1 along the axis of Z in the first frame? The only answer here is theta1. Same as the second one now.
Oh,
Eh?
okay.
Who's that? You get it?
Yeah.
How are we going to rotate frame 1 and frame 2 along the Z1 axis? The answer also is theta 2. Please, who doesn't understand this? If you don't understand this, I'm not going anywhere. You have to understand it. It's like Wilson is one that usually have all this definition of fan. Is it correct?
Samuel,
What's up?
sorry, that theta frame 1 and frame 2, they're already in the same axis. Is there need for rotation?
Theta 1 and
The frame 1 and frame 2.
Frame 1 and frame 2. This one
Yes.
and this one. Yes.
They're already in the same axis. Do you have to rotate like
that's see. Put it this way. Theta is the rotation of Z. I think that's the best thing. Honestly, theta is the rotation of Z. What's the rotation of Z0? Is theta 1. What's the rotation of Z2? Is theta 2. Just put it that way. Forget whether the frame are the same or not. I think when we get to this is Cara. The next one we'll do is Cartesian. Maybe you guys will understand that one better.
Okay, I think I understand what you're doing, Jean.
Good. Is that okay now? Who doesn't understand the column of theta? You should talk now, because if you miss this one, you will not get it again. Please, now I'm begging you.
Samuel.
Yeah.
This is not constant here. It could change.
What? Yes.
All right. So when we do the next example, we'll see we see an example that the theta would change, or it have like a positive or something,
Yes, or, to be like 90, to be like I will see that. Especially when it's prismatic, we'll see that.
Okay, when we get there, we understand more. So please go ahead.
Yes. Okay, thank you. So let's go. Now, alpha. Alpha is, what is the rotation of what's the rotation of this frame?
Those stuff that is like is that alpha or it is A? Because you wrote it like A.
Alpha
in the diagram.
Theta is the joint angle. Alpha is the link twist. R is the link length. D is
that
the
A is R. The A in diagram is R.
Is it
this
A or
one,
alpha that is in the diagram? The one with green.
The one in the diagram is A2, A1 from the last class now. Yes, we know that's the displacement. Yes, from the last class. But yeah, what we are talking about here is alpha. So now alpha now is what is the rotation? Listen, it's a rotation parameter too.
Alpha is link twist, yeah?
The first one is a rotation parameter. It's not a rotation parameter. It is, but around Z. This one we are around doing now is around X. So it has to be X only. That one was Z only. Are you listening? But the first one I did theta is around the Z0. So if you are saying we are doing the parameters for frame 0 and frame 1, the theta is always for Z0. But this one now is also a rotation parameter, but we are doing alpha. This one will not be Z, no, it is Z0, the last one. This one will be X1, not X0. So look at what I'm saying now. So what is the rotation? What's the rotation? What's the rotation of this and this around X1 axis? Do you see? So what you are twisting now is the X1.
There are two types of this thing. Why are you not using it?
Sabi.
She person not go like mute.
The rotation of this and this.
Okay.
Yes, around this axis. So anybody want to try?
Hello guys.
Yes.
Yeah, I just got a notification that this meeting might end in the next 10 minutes.
Why?
So if it does, probably it's not paid. Actually, I'm trying to collect it to confirm. So if it happens, we will just create a new link, then we will join again.
Okay.
No.
Just let you guys know.
All right, thanks.
Can continue this.
It's Elvis. I beg, waiting to talk. What did you say?
So what I said is that what's the rotation of this and this around this axis, this x1 axis. So x1 axis is, see, the reason why this thing is always confusing is that I said x1 axis now doesn't mean we are rotating frame x1. It means we are rotating frame x0. I beg, let me get my screwdriver. If you don't understand what I'm saying, I can feel it. I know when somebody don't understand what I'm saying. Okay, this is frame.
I can't
This
screen you.
frame. I haven't seen what I'm doing.
Yeah, we can see you.
Okay. This is frame. Look at me and look at what I'm saying. This is frame 0, right? This is where x0 is facing.
Okay.
Right? Good. In frame 1, x0 is also facing this direction. Right?
Yes.
Good. But it's not frame 1 we are rotating. It is frame 0 we are rotating along the axis of x1. So x1 now is like this. X1 is like this. But we are rotating this frame along this frame. So assuming y was facing here, it is still here would have rotated. You get?
Okay.
Good. So now we are rotating this frame now along this x1 frame. But lucky for us, this x1 and this x0, they are on the same frame. So we are just rotating x0. Assuming it was y0 that is facing here, we're not gonna say okay, it's x because this place is x1. We're gonna look for x0 here and rotating along the frame of this, but it's the frame 0 we're rotating. Frame rotation of frame 0 to frame 1 along this x1 axis. You get? So how do we rotate this to get this along this axis? Is it not like this? Shebi, so y can come up and z can come the other way, right? And that's what? Is it positive or negative?
Anti-clockwise, that's
That's positive.
90.
Sorry,
90
Samuel,
is positive 90.
That's
come
positive
again.
90.
Samuel, please come again. That part just explained.
Listen. What we are rotating is the first frame. The first frame here now is 0 because we are still working with 1. We are in 1 now. So we are rotating this frame with respect to this frame, but along the x1 axis. So even though this one is x0, yes, we are rotating x0 now. So in this one, we are rotating like this. But assuming it was y that was here, we'll not say because it's y, we're not gonna look for x0 here and rotate. This is the axis, this is where this one is going. So whatever the angle it is here is what would have still rotated with this. So we are rotating this angle with respect to this angle in this direction. So is this direction we must skin to, this direction we must keep to, irrespective of whatever it is in this same one. So now we are the only way we can rotate this to this along this direction to get this is to bring this one like this. To take it to rotate it, and that's in the anti-clockwise direction, and that's positive 90. Is that okay?
Yeah.
Good. Now let's now do the second one. Let's do this. Who wants to try for the second one? Please, someone should try for the second one.
For the second one, I think it's going to be 0 now because I don't think there's any rotation. I should be all the axes are facing the same way. So I think 0, right? How far?
I think we lost him.
I think he's out.
Alpha, that face, me will like carry over.
No, thank you.
Why you laugh? And you laugh?
But you guys, when someone is teaching, if you guys know something, please put your knowledge. Don't just put it in on someone alone. I beg. No knowledge.
You can use your knowledge too, madam.
They already know the answer, but they know it's simpler method. Well, it's sorrow.
Alpha, why you fight?
I don't know.
We have 1 minute to move out of this Zoom meeting. Why they laugh? They think they funny.
They see the increase.
Hello, any.
In the new room, are you guys going to start again?
Since Samuel is out, can we just leave this meeting and create a new one?
Yeah, let's kick everybody
Kick
out.
them out as well.
I'm leaving before you kick me out.
So guys, you can just leave. We'll create another meeting and drop the link.
Elvis, cancel, end the meeting there. Everybody automatically get out.